Large language models power tools like ChatGPT, but most people don't really understand how they work. Some explanations are full of math. Others are pure hype. In this video, I'll explain how LLMs actually work in simple terms, without math and without exaggeration. Let's start with the most important idea. A large language model is not a knowledge base. It is not a reasoning engine, and it is not thinking. At its core, an LLM is a system trained to predict the next word, or more accurately, the next token. A token is just a piece of text. It could be a word, part of a word, or even punctuation. During training, the model sees massive amounts of text and learns patterns. It learns that certain tokens are more likely to follow others in a given context. That's it. When you type a prompt, the model does not look up facts. It looks at the context and predicts the most likely next token. Then it predicts the next one, and the next one, until a response is formed. This is why LLMs are often described as probabilistic text generators. Now let's talk about training at a high level. During training, the model is shown trillions of tokens from books, articles, websites, and code. It makes predictions, compares them with the actual next token, and adjusts itself. Over time, it becomes very good at recognizing language patterns. But this training happens only once before the model is deployed. After training, the model does not learn new facts unless it is retrained or fine-tuned. This is a key limitation many people misunderstand. Another important concept is context. When you ask a question, the model only knows what is inside the current context window. It does not remember previous conversations unless they are explicitly included. This is why prompt design and context management are so important in production systems. Now let's address an important question. If LLMs only predict tokens, why do they sound so intelligent? The answer is scale. Because these models are trained on massive data and have billions of parameters, the patterns they learn are extremely rich. This allows them to generate text that feels coherent, structured, and even insightful. But this does not mean the model understands meaning the way humans do. This is also why hallucinations happen. If the model does not have enough context, it still tries to produce the most likely answer, even if that answer is wrong. It sounds confident because confidence is just a pattern in language. The model has no built-in concept of truth. This is why techniques like RAG are used in production. RAG gives the model real, trusted information so it does not have to guess. Understanding how LLMs work helps explain many real-world behaviors. Why prompts matter, why responses vary, why models fail silently, and why production systems need guardrails. From a career perspective, this understanding is critical. Companies don't expect engineers to train LLMs from scratch, but they do expect professionals to understand how LLMs behave, where they fail, and how to design systems around them. If you treat LLMs like magic, your systems will fail. If you understand them as probabilistic systems, you can build reliable solutions. If this explanation helped you understand how LLMs actually work, subscribe to Practical GenAI. I share weekly videos on generative AI, MLOps, and AI careers, explained simply and practically.